This is now the introduction for foundation engineering and retaining walls, C49 and CE75. To begin with, what is the importance of foundation of a structure? Foundation, as being defined, is the member of the structure that connects it to the ground and transfers loads from the structure to the ground. As what you can see here in the image, it is the foundation wherein they are still doing and preparing, um, where it is the member that is directly connected to the ground. What is foundation engineering? So, foundation engineering is the application of soil mechanics and rock mechanics in the design of foundation elements and structures. Of foundation elements of structures. Of course, since the ground is made of soil and rock, then that is why we are learning in your previous subjects about geotechnical engineering. However, we are in Silliman University, we are tackling mostly on soil mechanics, soil 1 and 2, and a little bit less on rock mechanics. This is mainly because in our location, uh, like in the Philippines, we can mostly find uh, ground composed of soil, and most structures are um, constructed on soil and less on rock formations. But in some universities, they are also focusing on rock mechanics. I mean, they are more focusing also on rock mechanics. Then, what is a retaining wall? Since this subject is a merged subject, the old curriculum and the new curriculum, foundation engineering, and then right now it is added with retaining walls. Although in the foundation engineering, retaining walls is already part of that. But to define retaining wall, it is a rigid wall used to support soil laterally to retain the soil to a slope that may erode due to natural and unexpected movement of the ground. As what you can see here in the image, it is a retaining wall in the form of gabion, but there are lots of retaining wall in which we are going to discuss one by one later as we go later in our discussions. What are the basic requirements to have a good foundation? First is the design and the construction of the foundation is done such that it can sustain as well as transmit the dead and imposed loads to the soil. So it means you have to determine all the loadings involved in the building, live, dead, and imposed loads, so that you will add up all these loadings, and since it will be carried by the foundation. This transfer has to be carried out without resulting in any form of settlement that can result in any form of stability issues for the structure. Second is differential settlements can be avoided by having a rigid base for the foundation. Of course, if you are designing a foundation, all you have to think is to make it rigid. These issues are more pronounced in areas where the superimposed loads are not uniform in nature. So, as we go along with our discussions, we are going to talk about settlements of structures and superimposed loads, but I believe that you are already familiar with these terms. Third is based on the soil and area. It is recommended to have a deeper foundation so that it can guard any form of damage or distress. These are mainly caused due to the problem of shrinkage and swelling because of temperature changes. So that is why before you're going to build your structure, you need to have soil test on the area where your structure should be will be located. This is to know and to consider together with your design the quality of soil that you are working with. And it is very important because if you do not know the quality of soil that you are working with in your design, then your design, even if it is, even if you're a good designer, but the soil will not um, um, be compatible to your expectations, then it your design will basically fail. So soil testing is really a must, especially if you are doing a high-rise building. Fourth is the location of the foundation chosen must be an area that is not affected or influenced by future works or factors. One example for this is if you are avoid try to avoid building or doing your structures and areas near highways or near national highways or the proposed roads, because basically when road widening will happen, then maybe some part of your foundation will be affected, then it will cause a huge impact to your design. What to do if you are to design the foundation of a building? Of course, first is to distribute the weight of the structure over the entire floor area to avoid overloading the underlying soil at some portion to prevent settlement. So we should always prevent settlement of the structure that we are designing. As what you can see here in the image, it is clearly seen that the foundation is evenly spread over the entire floor area of the structure. Next is prior to the design, you should know all the loadings of the structure from top to bottom. So from top to bottom, as it is the foundation which should be carrying all of the weight of your structure. So you have to know the loadings starting from the roof, including all the structural members, columns, beams, floors, floor joists, and everything from top to bottom because it will be carried by your foundation. What is settlement of a structure now? Try to check the image in the right side. So this is the settlement that happened to a certain house. Settlement, it's a different term if we are talking it in an engineering application. So by definition, it refers to the distortion or disruption of parts of a building due to an equal compression of its foundations, then due to shrinkage, such as that which occurs in timber frame buildings as the frame adjusts its moisture content, or the cause of it is undue loads being applied to the building after its initial construction. So there are three considerations why settlement of a structure would happen, but as what you can observe that unequal compression of its foundations is importantly highlighted. It's because once you are designing your foundation unevenly, then you cannot expect a uniform distribution of the loads from your structure going to the ground. And I think that is also part of our introduction. Then you can check on our next discussion. Thank you.